Okay, today this is our tutorial 7 live session class. Today we are going to discuss about volume of a solid of revolutions. So what do you mean by solid of revolutions? Okay, let's try to fill with graphically. Then we'll define the definition of what do you mean by solid of revolutions. Okay, suppose you have so x-axis, y-axis, this is your curve. Okay, y equal to fx. Okay, so I am bound this x from 0 to a. So this is your plane bounded by this curve y equal to f of x, and this x-axis and x equal to a line. Okay, so this is one plane. Okay, so and this is your one fixed line. Okay, so now you have to do what you have to do. You have to do rotate the plane, okay, about this line in the same plane. Okay, so what we have to do, we have to do rotate this plane region, okay, this plane about this line, okay, in the same plane. Then you will get one solid. Then what is our aim? Our aim is to find the volume of this solid. Okay, so it will look like if you revolve this region, okay, about this line, it will looks like little bit this kind of things. Okay, yes, this is like, okay, yeah, you can think like that. Okay, okay, so if this planes is revolve around this fixed line, then we will get one solid. Okay, looks like this one. So what is our aim? Our aim is to find the volume of solid revolves about around rotating around one fixed point, okay, in the same plane. So now I am defining what is the solid of devolution. Okay, the solid obtained by, okay, the solid obtained by rotating a plane, okay, rotating a plane region, okay, about a straight line in the same plane. Okay, in the same plane is called a solid of is called a solid of revolution. So what we have to do, we have to do that this is one plane, okay, bounded by this curve y equal to f of x and x-axis and x equal to a lines. So we have to do that, we have to rotate this plane, okay, about this line in a same plane. Then we will get one solid of revolution. This is the definition of solid of revolution. The solid obtained by rotating a plane region, okay, about a line in the same plane is called a solid of revolution. Okay, and the line is called axis of revolution. Okay, the line is called the axis of, the line is called axis of revolution. Okay, now our question is how we'll find the volume of that solid. Okay, this is our main aim. Okay, so one things you can observe. Okay, let's divide this like a Riemann integral. Okay, so how one can find the area of a some particular region. Okay, so what we'll do, we'll divide this interval. Okay, we'll divide this line in a n sub interval. Okay, it's fine. Then we'll looks for the volume of one particular region. Okay, volume of some particular slice. We'll cut one slice here. So this is your solid. Okay, yeah, revert. It's this is your solid. How we obtain? We rotate this plane around this line and we got this. Okay, this got this solid. So now we'll take a little slice here. Okay, take one little slice here. So this slice, we take little slice here. Okay, and this is your Rx. Okay, this one. Okay, so now our first aim is, what is our aim? We will divide the x-axis. Okay, not x-axis, the revolve of that straight line. Okay, suppose this is bounded by suppose if that interval is bounded by a less equal to x less equal to b, will divide this interval ab, okay, into a nth subinterval. Okay, I'm writing properly. Okay, so suppose the region is bounded above the curve y equal to f of x. Okay, suppose the region is bounded above by the curve, okay, y equal to f of x and below by x-axis. Okay, where your axis lies between this one. Okay, to find the volume of solid. Okay, so our interest is to find the volume of solid. How we get the solid? It is generated by this plane. Okay, so when this plane is revolves around this straight line, so we'll divide that interval AB into a n equal parts. Okay, so to find the volume of solid, okay, to find the volume of solid, okay, so generated, we divide the interval, we divide the interval into n equal parts. Okay, we'll divide the interval AB into n equal parts. Let the partition be, okay, this is your partition, this is your interval AB. We are dividing this one into a n subinterval. Okay, so now our aim is, we'll take one slice. Okay, we'll take one slice. So what is the volume of that particular slice? If you look, that slice is nothing but one cylinder. Okay, this with very small height. This height is all nothing but your, if you take that ith subinterval, this height is nothing but your xi minus 1. This is your height. Okay, and what is your this radius? This radius is nothing but your fx. Okay, we will take fx I star. Okay, where your ix star is belongs to that sub interval. Okay, this is your height, this is your radius. So we already know the what is the volume of cylinder. Volume of cylinder is nothing but pi r square into height. Okay, so this is our main aim. Okay, then we'll take the sum of full on the full interval. Okay, on the ith sub interval, we approximate the slice. Okay, slice of solid hello, are you able to hear me? Hello. Okay, left it. So today we are going to discuss about volume of a solid of revolutions. Okay, solid of revolution is nothing but take a plane. Okay, it is bounded by someone to also take one plane of region. Okay, bounded by suppose fixed axis A is between A and B, and take another some condition such that we will get one region like that. Okay, so solid of revolution is when this region will be revolved around this axis, we will get one solid. This is a solid of revolution about some line. This line is called axis of revolution. So we are going to find the volume of these solids. So what we are going to do, we are, so suppose this is this so our curve is suppose y equal to f of x, and region is bounded by y equal to f of x curve, and below is x axis where x is between a less equal to x and less equal to b. Okay, so this is your region bounded by this one. Okay, to find the volume of solid, so generated we are dividing the interval AB into nth sub interval. Okay, this all sub interval are equal size. Okay, so now what we are doing, we are taking one small slice from that solid. So this solid is nothing but a cylinder. If you, okay, this slice is nothing but a cylinder. This height is very small. This is height is the length of the ith sub interval. And what is the radius? Radius is nothing but the f of xi star, where xi is belongs to this sub interval. Okay, it's fine. Yeah, so on the ith sub interval we approximate slice of solid by, okay, by f of xi star whole square into xi minus 1 for a point xi star belongs to xi minus 1 x. Okay, hello, yeah, are you able to hear me?
Oh, it's audible.
Yeah, so basically today we are going to discuss about volume of a solid of revolutions. Okay, so what do we mean by solid of revolution? Suppose you have this plane, okay, bounded by the x is between this one. This can be anything, but I am right now for convenience we are fixing x this one, okay, and take this line x equal to a. So this is your one plane of region. So what is the solid of revolution? Solid of revolution is nothing but, suppose this is your plane, okay, region, plane of region, where revolve around this plane of region around about this line. So we'll get one solid. So this is the solid of revolutions, okay, and the axis is called axis of revolutions. So what is our aim? Our aim is to find the volume of that solid of revolutions, okay. So what we are going to do, so this is your that solid, okay, solid of revolution. So we are going to find the volume of this solid of revolution. So at first we are doing, so this is your x is bounded by suppose a and b. So at this is one interval. So our next step is going to, we are divided this into a n equal sub interval, okay, like Riemann integral. We'll calculate area in one particular sub interval, then we'll take the sum. Here we'll do same things. We'll find the volume of some particular region, okay, then we'll take the whole sum, okay. This is our aim. So from these solids I am taking this slice of solid. This slice of solid is nothing but a cylinder, okay. This small cylinder whose height is nothing but the length of the ith subinterval, okay. It's fine. Then what is the area of this cylinder? Is nothing but pi r square is, or where r is the radius of that cylinder, radius of the circle of the cylinder, and is the height, okay. So yeah, so this one on the ith subinterval we approximate the slice of solid by pi f of xi star whole square into this quantity, the length of the subinterval. For a point we are taking xi star belongs to from this I subinterval, okay. Then this is for only the ith subinterval, okay. Now what will be happen for whole that solid of revolutions, okay. The natural is we will take the sum over full interval, okay. Then the volume of the solid of revolution is approximated by the sum, okay. We'll take sum over full interval I equal to 1 to n pi f of x star whole square into length of the ith subinterval, okay. This is, now we are getting the approximate, okay, volume of solid of revolutions. This is approximate, okay. So now we'll take the limit n tends to infinity, then we'll get the volume of the solid of revolution, okay. It's fine. Now the volume of solid of revolution is the limit of this sum. If you take limit, okay, n tends to infinity, this sum into this one, okay, we will get the volume of solid of revolution, okay. It's not coming, going wrong, yeah, it's not coming now.
Screen share is not visible.
My screen is not visible.
Not.
Oh, 1 minute. Now it is visible.
Now it's visible.
Okay, okay, thank you,
Like,
thank you. Yeah, yeah. So yeah, this is our approximate, okay, this is our approximate volume of solid of revolution, okay, because there we are taking this fi this is so at first we divide that interval into nth subinterval. After that we are taking the volume of particular one slice, then we are taking the sum over whole interval. So that time it is, we are calling this is approximate, because sometimes it's may be high, may be low, because we are taking this f of xi star from that interval. Okay, so if this is uniform on that interval, then it's fine. If it's not uniform, that value of f of xi on that interval, then we will get either little bit low or little bit high the volume of that slides. So for the reason we are taking, we're telling that this is the approximate, okay, approximate volume of solid of revolutions. Okay, fine. Again, is visible or not? Okay, I think visible now. So now if you take the limit of this quantity, we will get the exact volume of solid of revolution. This is the V, and where V is the volume of solid of revolution. Okay, here one things we can observe, that the cross sectional area for x belongs to AB is, what is the cross sectional area? What is the cross sectional area? Area is nothing but pi, what, part pi r square, where r is your nothing but f of x. Okay, is fine. The cross sectional area AB is nothing but x equal to pi f of x the whole square. Okay, if your this ax is continuous function of x, then the limit of above sum is required volume, and that is represented by, okay, this limit. Okay, this limit will be equal to v is equal to integration a to b ax dx, means integration a to b pi f of square dx. It's fine. If your cross sectional area this ax is continuous, okay, then this v is exactly equal to integration over a to b ax dx, where ax is nothing but pi f of x square the whole square, this one. So this is the formula for finding the volume of a solid, okay, of revolutions. Okay, one thing you can note here, initially we take the axis is x axis. If your axis is any other axis of revolution is not x axis, suppose here we take the axis of revolution is only x axis, it may be here, it may be here, but same case formula will be same, or all those cases. Okay, because if you observe how we derive this formula is not depend on axis of revolution. Okay, only depend on this plane region. Okay, so if your axis of revolution is this one, same, fine. If axis of revolution is this one, okay, this same formula will work, no issue. Okay, yeah, when your axis of revolution will be this one, that time only your variable will be changed. That time we are revolve around y axis or parallel to y axis. That time here we will get integration, we will take the range of y and pi f of y x square dy like that. Okay, it's fine. So what is your note is, if the axis of revolution is a straight line, other than the x-axis, okay, similar formula can be obtained for the volume of solid of revolutions. Okay, now I will look for few example. Okay, where first we will take very simple example. Okay, so if you look here, okay, yeah, so this one is nothing but your y equal to root x, this curve. Okay, so I am telling to find the volume, okay, of the plane region. Plane region is bounded by y equal to root x, and x is from your, take 0 to 4, take here a equal to 4, okay, and take this one is only, so x this one will get this bounded region. So find the volume of solid of revolution. So this is my first question. Okay, our region is the region between the curve y equal to root x and x is vary from 0 to 4 and the x axis, okay, is revolve around x axis. Okay, so what is our region? Our region is between the curve y equal to root x and x is vary from 0 to 4, means take y x equal to 4 line and the x axis. This is our region. Okay, so this is your y equal to root x curve, x is vary from 0 to 4, take this one y equal x equal to 4 line. This is your region. Okay, and this region is revolve around your x axis, this is axis of revolution. So you have to find the volume of the solid of revolution. Okay, find the volume of the solid of revolution. Okay, so what is our formula? Is from v is nothing but your integration 0 to 4 pi f of x square into dx. So 0 to 4, what is your f of x? Is nothing but your root x, okay, pi root x square dx. So it's coming like 0 to 4 pi x dx pi x square by 2, 0 to 4. Okay, so this is coming is your 8 pi. Okay, this is the required volume of the solid of revolution by this given plane region. Okay, now we are going for, we already know the volume of sphere. Okay, 4 by 3 pi r cube, we already know. So now we are going to prove of that formula. Okay, so from 10 standard we already know what is the volume of one sphere, is where the r is the radius of the sphere. We already know that 4 by 3 pi r cube. Okay, so now today we are going to prove the what is the volume of a sphere whose radius is r. Okay, so my next question is, find the volume of the sphere. Okay, x square plus y square plus z square equal to x square. Okay, so you have to find the volume of the sphere. Take a equal to 0. Okay, so here we are talking about solid of revolution. So how, now one can think how will get one sphere. Okay, if you revolve one region, if you revolve which region, that will get the sphere. At first you have to think that which region we have to revolve around some axis, then we will get the sphere. Okay, obvious choice is semicircle. If you take the semicircle, okay, and take the full semicircle and the full region, this one bounded by semicircle and this x-axis, then revolves around this one, definitely we will get one sphere. Okay, this is our obvious choice. Okay, here a is your radius. Okay, so take this semicircle minus a to a and take this full region. Okay, and revolves around this your x-axis, then we will get, this is your semicircle, take this full region bounded by this x-axis and semicircle and revolve this semicircle around this axis, we will get, what we will get, we will get a sphere. Okay, so we can think sphere as the solid of revolution of the region bounded by the upper semicircle, x square plus y square equal to a square, y is your greater equal to 0. Take the upper circle only. Okay, you can take lower circle also. I am taking upper circle, upper semicircle. Okay, so we think of the sphere as the solid of revolution. We think of the sphere as the solid of revolution of the region bounded by the upper semicircle. Okay, what is the upper semicircle? It's x square plus y square equal to square y is equal to greater equal to 0. This is your upper semicircle. Okay, and here your x is minus L is equal to x, less equal to a. Okay, it's fine till now, it's fine or not? Please tell me how we are getting a sphere. We are getting the sphere, it's nothing but revolve of upper semicircle, not an upper semicircle bounded by this is an upper semicircle and this is your x-axis. Okay, x is between minus a to a. Then when you will go for revolve of this upper semicircle, this region around this axis, will get the sphere. Okay, now what is your curve? This is your semicircle, and what is your curve? Y is nothing but x square minus root over x square minus x square. Okay, this is your curve. Then the volume of the sphere is V equal to nothing but minus a to a pi. What is your curve? Curve is this one. Okay, root over x square minus square whole square dx. Okay, it will, if you calculate, it will come 4 by 3 pi. This is our known formula. Okay, and here using, yeah, so from 10 standard we already know about the volume of the sphere is 4 by 3 pi r cube, whereas the radius of the sphere. Today we prove that using using the formula of volume of solid of revolutions. Okay, now we are going for the next question. Take another, yeah, so for this one we need one another concept. Okay, so at first I'm going for
Hello,
that
sir.
one. Please tell.
Yeah. Sir, I joined late now, sir. So, what was the topic that you are discussing?
Okay, I'm telling you in a short. So this, our topic is, today topic is volume of a solid of revolutions. Okay, what do you mean by solid of revolutions? Solid of revolutions is nothing but you have one plane region. Suppose take this plane region. Okay, this is your plane region. When you will revolve that plane region around one axis, about one axis, we will get one solid. Definitely, is it or not? So we have to find the volume of that solid. Okay, so here we derive the how to find the volume of solid of revolution. So ultimately we get this formula. Okay, ultimately we get this formula if your region is this one. Okay, about, and this plane region is revolves around your x-axis. Okay, so we get this formula where fx is your curve. Okay, y equal to fx your curve. Okay,
Yes, sir. Yes, sir.
yeah, so here basically you are taking r is your fx, this r, this height is definitely this fx na height is. So this is taking as a radius. If you go through our derivation na, so this is your solid, okay, of revolutions. So at first we take the small slice from the solids. Small slice, it looks like cylinder. Okay, and what is the radius of the cylinder is nothing but this height, rx is your fx. Okay, but that time we are taking this xi star is between that small sub interval, ith sub interval, this sub interval. Okay, so this is the radius of that slice. Okay, so we already know the formula for the cylinder, it's nothing but pi r square, is where r is the radius, where here radius is your f of xi star for that ith interval. Okay, I am taking, and length is, height is nothing but length of that interval. Okay, so this is the volume of the slice. So after that we take the sum over full interval. Okay, so definitely this is the approximate sum, because for the ith interval we are taking the f of xi star, that radius, this may be, if this is uniform, this is fine, this is exact volume. If it's not uniform, it may be high and low, high and low, you understood na, that time something gap may be there. So for this reason we are telling this is the approximate sum. After that we are taking the limit. Okay, after that we are getting the volume of the solid of revolutions. So now this is a little bit difficult to calculate, it is not that much easy. Okay, after that we are replace this one using our calculus. Okay, so here we are taking the cross sectional area is pi f of x square, basically area of the circle is pi r square. Okay, here your r is the height, f of x. Okay, so cross sectional area is nothing but this one, is depend on your x. If your x is continuous, that this volume will be exactly equal to this integral only, integration a to b ax dx. Okay, and your x is pi f x square whole square dx. Understood, Ravi?
Yes, sir.
Okay, so after that we go through one simple example. Okay, so this is our one interesting problem you can tell, because from 12 standard you already know the volume of the sphere. Okay, 4 by 3 pi r cube. Okay, but today we
Yes, sir. 4
derive,
by 3 pi r cube.
yeah, using the volume of solid of revolution. So how we'll get the one sphere? If you take the upper semicircle and take the full region, yeah, this is upper semicircle and I am taking this region bounded by this x-axis. X-axis belongs, x is vary between this one, and if you revolve this region about your x-axis, we will get the sphere. Is it or not?
Yes, sir. 180-degree rotation.
Yes, fully. Okay, this is your upper semicircular region. We have to rotate fully. Okay, is it?
Yes, sir.
Yeah. So we will get the sphere. And what is this curve? Is nothing but, this is the upper semicircle, x square plus y square is square, where y is greater or equal to 0. We are taking upper semicircle, so your y will be always positive. Okay, so what is the curve? Curve is nothing but y equal to square root of a square minus x square. Okay, now we know the formula. So the volume of the sphere is pi f of x the whole square dx, and your x is varies from minus a to a. So ultimately we will get this one. Okay, it's fine.
Sir, we are using pi r square, no? Here.
Yes, pi fx square.
Okay.
Yes, because for every ith interval we are taking r is a f of xi static, if xi belongs to that interval, so approximately this is f of x only. Okay, it's fine, Ravi?
Yes, yes.
Okay, now here our region was contacted with our axis of revolution. If our region the plane region is not bordered the axis of revolution, then what will be happen? Understood or not? So here this was our region. Okay, and this region was revolve around this x-axis. After that we are getting the one solid and we are trying to find the volume, and we know the formula. If here you observe our axis of revolution is bordered the plane region, this is the in the border of the plane region. Okay, if it's not the case, means suppose this your plane region is this one, suppose this is your plane region and we are revolving this plane region around this axis, about this axis, you can do na. So this is your axis of revolution, and this is your that region. If you revolve around this one, okay, we will get one solid, but in middle one hole will be there, because this is your region, we are revolving around this line. Okay, so in middle nothing will be there na, middle hole will be there only, solid will be in upper portion only. Is it or not?
Oh, yes, sir. Yes,
Yes, sir. Yeah,
hollow sphere.
yeah, one not hollow sphere, but that type of things will be there. Suppose this is your that region, if you revolve around this one, okay, in middle some hole will be there. Okay, so how we'll find that volume of that solid? Okay, when your axis is not attached to your plane region. Okay, this is also very simple, because that time at first we will take the upper one and take the full region up to this one. Okay, take fully and revolves around this axis, we will get one big solid of revolution. Okay, after that only this lower portion, and take this one as a region and take the volume of find the volume of solid evolution, then subtract both, will get the only exact volume of that solid of evolution. Is it or not? It's fine.
No, sir, I did not.
You did not get. Okay. Nice.
Sir, how can that plane be outside the region of a sphere? That rotating plane,
Sorry.
that axis, that rotating axis,
Hmm.
how, how it can be outside the region of a sphere?
Not region of sphere, outside of the border of the plane region. This is not a sphere, this is one region only. Okay, is it or not?
And the axis is x-axis.
This one is your axis right now. Okay.
Hmm.
Yeah, so go for the revolution. Okay, in this way. So for big, for this one, you, for the upper curve, you will get one solid of evolution. Is it?
Oh, yes.
For this one, for lower curve, you will get one solid of evolution. But for this case, for this whole case, okay, this will be empty. But for bigger one, na, for bigger one, okay, so it will be looks like that. Okay, this is our whole, this one middle portion, and upper portion will fully will be solid. Okay, is it or not?
Oh, yes.
Understood? Please tell me, understood or not?
Oh, yes, sir.
Okay.
Sir, then
Now,
how we can find that volume of the
yes,
sphere?
yes. This is the question. How will find the volume? Okay.
Sir, so sir, then the radius of the inner one and the outer one will vary.
Yeah, for outer one, if you take this interval, what is the outer one? Radius is f of, if suppose this is your f of x, okay, then it will be f of x, rx is f of x, and suppose this is your something g of x, so your rx will be g of x. Is it or not? For this sub interval will be this one, this one. Take star, no issue. Is it or not?
Oh, yes.
Yes. So what we will do? We'll at first we'll look for, we'll not look for the lower one. At first we'll take for upper curve. Take the volume. Find the volume. We know for upper one pi f of x whole square. This is we already know. And take that x is from a to b. We know this, for this one is for volume of revolution for upper one only. Okay. It's fine.
Yes, sir.
Now find for lower one. What will be lower one? Pi hx square dx. Is fine.
Sir, this A to B will remain same in both cases.
Yeah, your this one is fixed, na. This one is fixed. Axis of revolution is fixed. We are not
Okay.
varying the axis of revolution. X is vary between this one. This one is fixed. Is it or not?
Yes, yes.
Yes.
And we'll subtract.
Yeah, we'll subtract both two. Then what will get? A to b pi f of x square h square into dx. Is fine?
Yes, sir.
Yeah. So now we are going for one example. Okay. So find the volume of the solid, okay, obtained by revolving the region bounded by the curve, okay, bounded by the curve y equal to x square, this is one, another is y equal to 2x about the y axis. Here we are taking the axis is y axis, okay, about the y axis. At first draw. So at first you have to find which one is your upper one, which one is your lower one, okay. So if you draw the curve, y equal to 2x means this one, okay, this is y equal to 2x and this is your y equal to x square. It's fine, okay. So what is the point of intersection is this one, okay. You can find the point of intersections, okay. Point of intersection is nothing but y equal to 0 and y equal to 4, means x equal to 2 is the x equal to 0 and 2, okay. When x equal to 0 we are getting y equal to 0 and when x equal to 2 we are getting y equal to 4. So y is vary from 0 to 4 only, okay. It's fine. Take one slides, okay. So this distance is nothing but it is smaller one, take rx, okay, and this distance is your for highest one, take capital Rx, okay. Yeah, for small rx we are going for take y, sorry, this is height, no, y, take y, yes, fine. So ry is nothing but for this smaller one, this is your smaller one represented by this one, so we'll get y by 2, okay, and for capital ry is bigger one, we'll get root y, is fine.
Sir, one question, please, sir.
Sorry,
Question.
huh?
Sir, one question, sir. Question.
Okay. So you have to find the volume of the solid obtained by revolving the region. Region is bounded by this curve y equal to x square and y equal to 2x about the y axis. So this is your only, this is the region, okay. And you have to revolve this region about this. This is your y axis. This is the region, okay. You have to revolve around y axis, okay. So this is y equal to 2x curve, this one is, yeah, so this one is your y equal to 2x curve and this one is y equal to x square curve, okay. This fine.
Oh, yes, sir.
Yeah, so this is your for smaller one, this is the radius for your smaller one, okay. So this distance from y to this one mainly basically, so this is nothing but y by 2, okay. It's fine, it's fine.
Yes, yes.
Yeah, for bigger one, this the full, take this distance from y to this one, it's ry. So ry is nothing but your root y, okay. It's fine.
Oh, yes, sir.
Yes. So what will be the required volume? Please tell me the formula for required volume. V equal to pi
Sir, integral pi
r square,
root y square.
this one. Since this is about y axis, so we are taking y variable, okay. If it's about x axis, we are taking x variable, okay. It's fine. It's fine, Ravi.
Oh, yes, sir. Sir, and the integral limit?
Yeah, please tell what is the limit here to here.
Sir,
What is this height?
0 to 4 or what it is?
Yes, 0 to 4, na? 0 y is vary from
Yes.
0 to 4 up to this one, okay, up to that one is fine.
Yes.
Yes, 0 to 4, okay. So 0 to 4 sorry 0 to 4 pi. What is r? R is nothing but root y minus this is y by 2 0 to 4 or is 0 to 4 pi. This root y is y minus y square by 4. If you calculate, you will get something 8 pi by 3 like that. Okay. Do you have any question?
No, sir.
Yeah, so today I'll stop here, and next class we will discuss about double integral. Okay, it's fine.
Yes, sir.
Okay, yeah, then bye bye for next class. See you in next class. Okay,
Okay.
yeah, please
Okay, sir.
join. Yeah.
Okay.
Tamil, are you able to hear me?